So let's solve the inequality with the modulus sign. We have done an equation earlier, pretty much the same thing, there is no difference. If I give you mod of x is greater than or equals to 3, let's say, how do I do it? Split it into two equations, two inequalities. Plus of x is greater than or equals to 3, minus of x is greater than or equals to 3. So what do I get? X is greater than or equals to 3. This will be send it to that side, this side, so I will get minus 3 is greater than or equals to x. So I can, if I have to understand, right, let me draw a number line to show you what I am talking about. This is minus infinite, this is plus infinite. So I have 3, then I have, let's say, 0 here and minus 3 here. So what is this particular inequality saying is that this inequality is satisfied for all of these values, because x is less than or equal to minus 3. Right, x can be minus 4, minus 5, minus 6, minus 100 and so on, and x can be, it's like r, okay, this or this, and x can be greater than or equals to 3. That means x can be more than 3 as well. So any value from 3 to infinite and any value from minus infinity to minus 3 is acceptable for me. So this union, this or this, right, anything in this range is fine for me, not between minus 3 to 3. If I put x is equals to, let's say, 1, 1 is not greater than or equals to 3. If I put minus 4, minus 5, minus 6, let's say x is equals to minus 6. What is mod of minus 6? It is 6. Is it greater than or equals to 3? Yes, this is true. If I take this as 10, x is equals to 10. What is mod of 10? Is 10. Is it greater than or equals to 3? Yes, this is true. So all of these values are true except this. If I take x is equals to 1, I said mod of 1 is not greater than or equals to 3. So this is wrong, right? That's how you solve it. Again, same thing, remove the mod, put the sign, don't put on the right side, okay, it might be confusing, put it on the left side always. Wherever you're removing the mod, put the plus and minus for that. That's the conceptual outlook that you should have. So remove the mod, two possible cases, plus and minus, solve them, and then once you get the answer, just make sure you check the range once properly and understand it. Very simple one. Let's solve slightly tricky one, not tricky actually, slight extension to what we have discussed. Give it a shot, same, remove the mod, plus minus two possible equations and try to understand the the entire range of inequality. Hope you have tried. So let's see this. One case will be plus of 5 minus 2x is less than minus 3x. Let's play with this, send it this side. So minus 2x plus 3x is less than 5. Sorry, minus 5, because plus 5 becomes minus 5. So x is less than minus 5. This is one part of the inequality. The other side will be minus of 5 minus 2x is less than minus 3x. So it is minus 5 plus 2x is less than 3x. Send it this side. So minus 3x, right? Minus 3x. So it will be 2x plus 3x is 5x is less than 5. So x is less than. If you carefully see this, you will see this. What is this saying? This part of it, I'll show a different color, right, 0, like 1, let's call it minus 5, okay. So this part of inequality is saying x should be less than or equals to minus 5. That means x should be in this chain. I take minus 6, minus 7, minus 100, all of these are fine for me, okay. And this part of it is saying x can be less than 1. This is also saying x should be less than 1. So that is like this, right, in this zone. Let's see, let me just substitute back and see if x is less than 1, let's put x is equals to 0. What do we get if we get x is equals to 0? 5, LHS is 5, RHS will be 0. Is this less than 0? No, right? Something we have done a wrong, let me see, I could have done a silly mistake here. Minus of 5 minus 2x, so minus 5 plus 2x is less than. So this one, x is less than 1 is what we are getting from this inequality, but the values are not being satisfied. Right, as I was showing, if x is less than 1, that means x can be 0, can be minus 1, minus 2, minus 3. Let's put it minus 2, for example, minus 3. What do I get? Mod of 5 minus of minus 3 will be 6, sorry, minus 2 into minus 3, right? So it is 11. What is the RHS I am getting? Minus 3 into minus 3 is 9. Is this true? No. 11 is not less than 9. This is also wrong. So this inequality seems to be a bit off in this case. What about this side? If x is less than minus 5, I can check minus 6, x is equals to minus 6. What do I get? 5 minus 2 into minus 6 is 12, so it is 17. The RHS will be minus 3 into minus 6 is 18. So 17 is less than 18. This is true. So this is the correct range. The point is this, that to satisfy this, it has to be like less than minus 5 and less than 1, which means it has to be less than minus 5. So that's what you can see. You might get an inequality like this where there are two different regions, but here there is an overlap. So my x less than 1 means this is what we are talking about. This entire range from minus infinity to 1. But then within that we have another thing which is only talking about this range. So to satisfy both, we have to stick with this. So that both of them are happy. It's because x is less than 1 automatically means x is less than or equals to minus 5. So we will stick to this. I can also check it, as you can see the substitution of values. It is giving you clearly that these values are not correct. Even if I put minus 5 for example, right? 5 x is equals to minus 5 for example. Mod of 5 plus 10, you will get 15. This side is also minus 3 into minus 5 is also 15. They are equal. That's not less than equals to. So again, this is also wrong, right? As you clearly see, x should be less than minus 5 is the answer for this inequality. So just make sure that you solve the inequalities and just substitute and check carefully. Here it was clear. So I just took a couple of values, it was clear. Here if I checked, I realized this is overlapping and sort of contradicting. So the best answer is obviously this. These values are not satisfying the given inequality. So solve the following equation. So it should be inequality again. Right, same approach, let's do this. Plus of 3x minus 6 is greater than or equals to 5x plus 14. Send to this side. So 5x minus 3x is 2x minus 20. So x is less than or equals to minus 10. That's what one side of it is coming out. Other side will be minus of 3x minus 6 is greater than or equals to 5x plus 14. So it's minus 3x plus 6 is greater than or equals to 5x plus 14. Send it this side. So 6 minus 14 is greater than or equals to 8x. So x is less than or equals to minus 1. Again, this seems to be the previous case where we are getting a bit of contradiction. So let's try to understand, right? X is less than or equals to minus 10. So minus infinity to infinite. So I have minus 10. So first let's look at this range. Let me substitute back one of the values, minus 11, minus 12. I'll check minus 12 and 10 only, minus 10, because that can be equals to minus 10 also. Let me check if x is equals to minus 10, what's happening? Mod of 3 into minus 10 is minus 30, minus 6, that is 36. The RHS is 5 into minus 10 plus 14, which is minus 50 plus 14 is minus 36. Is this 36 greater than or equals to minus 36? Yes, this is true. So x can be minus 10. Let me put x is equals to minus 12. So 3 into minus 12 is minus 36. Minus 36 minus 6 is mod of minus 36 minus 6 is 42. What about the RHS? 5 into minus 12 plus 14. So minus 60 plus 14 is minus 46. Is greater. So all of these values are true. Now let me see the other one, this range. What is this talking about? It's talking about x is less than or equals to minus 1. So minus 1 will come, let's say here. It's talking about this range. What I will try to do is I'll try to check x is equals to minus 1. I'll try to check x is equals to minus 5. I think these two will give a sense of whether I can accept this range or not. So x is equals to minus 1 means 3 into minus 1 is minus 3, minus 6. So this will be 9. 5 into minus 1 plus 14. So it is minus 5 plus 14 is 9. So 9 greater than or equals to 9. Yes, this is acceptable. Let's try x is equals to minus 5. 3 into minus 5 is 15. Minus 6, so it's minus 21. So mod of minus 21 is 21. The right hand side will be 5 into minus 5 plus 14. Will be minus 25 plus 14. So it's minus 11. So again, this is also true. So that basically means this entire range is accepted. Let me check with 0, for example, right, which is outside these two ranges, right? X is equals to 0. What do I get? Mod of 0 minus 6 is 6. This is 6. If x is equals to 0, I am checking. What about this side? 5 into 0 plus 14, which is 14. Is LHS greater than RHS? No, this is wrong. right? If I check anything outside this, it's going to be a wrong inequality. So as you can clearly see, when you get two ranges, it can happen that a non-overlapping things, which is very simple, that all of these values would be happy if you substitute back. When you have overlapping things, check carefully if it's only one part of it or if it could be the bigger part. You just have to check both carefully and then understand. Right? So how do I check it? As I said, pick one value in this smaller region, another value in this bigger region, and then outside the bigger region. I think that itself will tell you whether you are correct or wrong. Right? I could see that with 0, -1, etc., which is in this region, this was proven to be wrong, solution. But this one is true. I check this one. If I check outside this, if I take x is equals to 2, 5 minus 2 into 2 is 4. So 5 minus 4 is 1. That's LHS. What is RHS? Minus 3 into 2 is minus 6. Is this true? No. So all these values are not valid. Only x is less than minus 5. So x equals to or belongs to minus infinity to minus 5. In this case, it was surprisingly x belongs to minus infinity to minus 1. So you just have to be careful. So square bracket, that's equals to. So just have to be careful with this, right? So inequalities are slightly tricky with modulus, but always remove the mod to the two inequalities, two equations, substitute it back. That's the thing that I would recommend you to look at.